Good morning, children. Today we shall talk about the characteristic of sound. We hear many sounds in our day to day life. Still, we are able to differentiate most of them easily. Let us hear few voices. Can we figure them out? Good morning. How are you?
Good morning, how are you? Good morning, how are you?
Good morning. How are you?
Good morning. How are you? Yes, this is the voice of a lady.
Good morning, how are you?
This is the voice of a girl.
Good morning, how are you?
This is the voice of a baby.
Good morning. How are you?
And lastly, this is a male voice. So we see the sound of a baby is different from that of an adult. Even if two sounds are equally loud, they differ in some way. We can recognize many familiar sounds without seeing the objects producing them. For example, just by listening, you can figure out whether it is a male voice or a female voice or it's your brother's voice in specific. Some sounds are loud, some are quiet.
Hello, bye bye. Hello, bye bye.
So, why is this difference there? These sounds must be different to enable you to recognize them. Have you ever thought what factors make them different? Let us find it out. We already know that the sound is produced by vibrating bodies. The to and fro motion of an object is known as vibration. We also know that the sound propagates in the form of a wave of vibration which moves from the source. In this, vibration repeats itself after a fixed interval of time. So, vibration is an oscillatory motion. Let us represent the sound as a wave form. We can say this is the height of the sound wave. How loud or quiet a sound is depends on the height of the sound waves. This is called the amplitude of vibrations. The amplitude actually tells us how far the vibrating object is displaced from its central position while vibrating. Let us listen to the sound at different volume or varying loudness. If we see the waveform of both the sounds, a loud sound has high waves while a weak or quiet sound has low waves. That is, their heights are different. One has a higher height and one has a lower height. And this height is the amplitude of the sound. The loudness of sound depends on its amplitude. When the amplitude of vibration is large, the sound produced is loud. When the amplitude is small, the sound produced is feeble. Actually, the loudness of sound is proportional to the square of its amplitude, although feelings of loudness are different from person to person. Now coming to the number of vibrations made, how do we say or represent whether the vibrations are slow or fast? So, the number of vibrations or oscillations per second is called the frequency of the oscillation. The frequency is expressed in hertz and its symbol is Hz for hertz. A frequency of 1 hertz is 1 oscillation per second. We can also say 1 Hertz equal to 1 vibration per second. Say if an object oscillates 25 times in 1 second, what would be its frequency? Yes, it will be 25 Hertz. So, if the frequency increases, it means more vibration or oscillations in a given time. You know, frequency is also defined as the number of waves passing through a point in 1 second. Now listen to the sound. Here, the loudness is kept same, still the sound is coming different. So what is different here? The slowness or highness of sound is the pitch. The pitch of sound depends how fast the object vibrates. Something that vibrates slowly makes a low-pitched sound. Something that vibrates very fast makes a high-pitched sound. For example, a sound with a low frequency will have a low pitch, such as a human's heartbeat. Or a drum beat. A sound with a high frequency will have a high pitch, such as a dog whistle. A bird makes a high-pitched sound, whereas a lion makes a low-pitched roar. However, the roar of lion is very loud, while the sound of bird is quite feeble. To reiterate, the frequency determines the shrillness or the pitch of a sound. If the frequency of vibration is higher, we say that the sound is shrill and has a higher pitch. If the frequency of vibration is lower, we say that the sound has a lower pitch or less shrill. Now we know sound may be loud or feeble and even pitch may vary, that is high-pitched or low-pitched. But how we are able to distinguish sounds which have the same pitch and loudness? Timbre is then a general term for the distinguishable characteristics of a tone. Let us understand the term timbre better. For example, if a guitar and a piano play the same note at the same loudness, maybe we won't be able to distinguish. But the experienced musicians will be able to distinguish this based on the varied timbres, even if those instruments were playing notes at the same pitch and loudness. Can we hear all the sounds? No, humans cannot hear sounds of every frequency. The range of hearing for a healthy young person is 20 to 20,000 Hz. The hearing range of humans gets worse with age. People lose the ability to hear sounds of higher frequency as they grow older. The highest frequency that a normal middle-aged adult can hear is only 12 to 14 kHz. If the frequency of sound falls within this range, it is called an audible sound. That is the range between 20 to 20 kHz. Do you know why we cannot hear some sounds while other living things like a bat can? We cannot detect some sounds which have frequency below the audible range of hearing, that is less than 20 Hz or above 20 kHz. It is said to be inaudible sound. Sound with the frequency below the audible range of hearing, that is less than 20 Hz, is known as an infrasound. Infrasound. and a sound with a frequency above the audible range of hearing, that is more than 20 kilohertz, is known as an ultrasound. Ultrasound. The human beings can neither produce ultrasonic sounds nor can they hear the ultrasonic sound. But some animals like bat produce ultrasonic sound during screaming. To summarize what we have learned today, now we know the different characteristics of sound. The loudness of sound depends on the amplitude. Higher the amplitude, louder the sound. The shrillness or pitch depends upon the frequency of the vibrations. Higher the frequency of vibration, higher the pitch of the sound. Also, the audible range for humans is roughly between 20 Hz to 20 kHz. Frequency below 20 Hz is called infrasound and frequency above 20,000 Hz or 20 kHz is called ultrasound. These are inaudible to humans. Sound is used by many animals to detect danger, warning them of possible attacks before they happen. And what is the study of sound wave known as? The scientific study of sound waves is known as acoustics. That is all for today. Bye bye, kids.